Okay, welcome again, grade 10 students. Inshallah, today we'll make a quick revision also on chapter which is called Energy of the Chemical Reaction or Energetics. When we talk about the energy of the chemical reaction in chemistry, we have to understand that during the chemical reaction we have reactant will give product. What does it mean? This means that during this process, there are two processes had to occur. First process include breaking bonds. Next process is called making bonds, making new bonds. So during the chemical reaction, the process of breaking the bonds, such as the reaction between, for example, hydrogen and chlorine. This is a common reaction for formation of hydrogen chloride, two molecules of hydrogen chloride. During this process, the breaking the bonds between two hydrogen atoms, and two chlorine atoms is followed by making new bonds between hydrogen and chloride ion, hydrogen ion and chloride ion. So the process of breaking bonds need energy, and the process of making new bonds, release energy due to the collision between particles to form a new bond between two molecules. The two molecules or the two particles have to join to each other or collide to each other, and as a result of this collision process, there is a great amount of energy will given out. So we can say that the process of chemical reaction or the chemical reaction, the forward reaction, is exothermic process, and the backward reaction is endothermic process or the contrast, because all reactions is different. What I want to say now, during the chemical reaction we have two process at which energy released and the process at which energy gained. The process at which energy released is called exothermic. The term thermic means temperature, means energy. Exo means outside, so energy will move outside. The process at which energy is gained is called endothermic. As we said, thermic means temperature, endo means inside. So during this chemical reaction, we have some process occurs, process called exothermic, and the process is called endothermic. And we have to understand that the process of exothermic always related to products. Why? Because during the formation of the products, there is a collision occur between particles, and to form new particles, to form new molecules, there is a collision occur, and due to this collision there is energy move outside. And the endothermic process is related to formation of breaking bonds at reactants, because breaking bonds need energy. So we can draw the process of exothermic and the endothermic process by using a curve called energy diagram. This energy diagram includes two axes, y-axis and the x-axis, and you can represent the reactant and the product, and the gap between them is the enthalpy change. At the beginning of the reaction, the temperature was 25 degrees Celsius, room temperature. At the end of the reaction, the temperature increased till it arrived to 100 degrees Celsius. So the difference between those two temperatures is called delta H, called enthalpy change, enthalpy. And you can plot the product reactant here and the product here. In fact, this occurs for exothermic reaction. Why this occurs for exothermic reaction? If you look at the position of reactant here, okay, and the position of the product here, while this y-axis include the energy and the y-axis or x-axis include the progression of the chemical reaction during the time, progression of the chemical reaction. But again, look at the position of reactant and the position of the product. You will note that at exothermic reaction, energy which is required to break the bonds between hydrogen and the energy which is required to break the bond between chlorine atoms is smaller than energy released after the collision between new chloride and hydrogen ion which form hydrogen chloride. So يبقى الانرجي absorbed for breaking the bond between hydrogen and chlorine atoms is less than energy, okay, absorbed during the formation of new hydrogen chloride. So the difference in energy here will found in the chemical reaction as exothermic reaction, and we call the reaction exothermic. So the difference in energy released during the chemical reaction. And by using this equation between hydrogen and chlorine, which is exothermic reaction, includes or the result of this reaction is high amount of energy, giving us 2 HCl molecule. We can calculate what's called bonding energy. As we know here, the energy of bonding, energy of breaking a bond at reactant, the energy here required is called energy of breaking a bond. The energy released here at products is called energy, okay, of formation new bonds or energy of bonding, okay, energy of bonding or energy of formation new bonds. So the energy change or the total energy change here can be calculated from a law, okay, which is called energy equal energy of breaking or energy of breaking bonds, okay, minus energy of formation new bonds, If we have energy for breaking bonds between two hydrogen atom, the energy here required for breaking the bond between two hydrogen atom is 436, and the energy required to break the bond between two chloride ions is 242. 12 gives energy, and the energy released during this collision equal 2 times 431 kilojoule. Okay, so these numbers I wrote, okay, represents the energy which absorbed or released during the reaction. For reactant, there is energy absorbed for break the bond. For products, there is energy released due to collision between particles. So we can calculate them by the composition, this relation here. the energy needed for break the bond equal 436 plus 242, all of those minus, okay, 2 times 431, the energy released, and the result of this process will be minus 184. The term minus means that it is exothermic, so this is called delta H for the chemical reaction, delta H. So the enthalpy change for this reaction is minus 184. We can do that for another example of the chemical reaction, or for the energy change, which is called endothermic. Endothermic reaction is the reaction which is followed by gaining a large amount of energy. Endothermic. What are reaction? Or in another way, if you catch the tube which has an endothermic reaction, you will feel it during the chemical reaction cold, such as a thermal decomposition of calcium carbonate. During the thermal decomposition of calcium carbonate, this reaction always, or to be completed, it needs high amount of heat to give calcium oxide and the carbon dioxide. Okay, so you can say here energy which is required for break the bond between calcium and the carbonate, okay, is greater than the energy which released from the collision between calcium ions and oxygen ions, or carbon ions and oxygen ions. Okay, so the energy here required for break the bond between calcium and the carbonate is greater than the energy released after the collision between particles here at products, okay, or energy of formation of new products. So there is a need for outer source of temperature, because during the breakdown of the reactants, it consumes all energy released from products and also need outer source of energy. So endothermic reaction is a reaction which gains energy. Endothermic reaction, during endothermic reaction, energy which required for breakdown reactant is greater than energy which released from the collision between particles of product to give new products. Also, it can be represented by energy diagram, which we will have at this process. As we said, energy which required for breaking the bond is lower than energy. Okay, we can represent reactant here, and we can represent product here, reactant and product, and we can represent the energy change like that, okay. So this is energy change, delta H is called enthalpy. So the term enthalpy equal energy change equal temperature change during the chemical reaction. And here we write energy, here we will write progression of the chemical reaction. So this all about endothermic and exothermic reaction. Okay, thank you for listening.